You are not seeing the world as it is. You are seeing the world as your brain expects it to be. Every color you recognize, every sound that feels familiar, every face that seems unquestionably real, none of it arrives in your mind as reality itself. It arrives as fragments, as electrical whispers, as incomplete signals. And in the silence between those signals, your brain does something extraordinary. It fills the gaps. It predicts. It constructs. It hallucinates just enough to keep you alive. Right now, your brain is not passively receiving the world. It is actively inventing it. The room you believe you are sitting in is not being shown to you. It is being generated for you, moment by moment, through a continuous negotiation between what your senses report and what your brain already believes. You are living inside a private simulation, one carefully tuned by millions of years of evolution to prioritize survival over truth. To say that reality is not passively perceived but actively constructed is to challenge one of the deepest assumptions most people carry about their own experience. The intuitive belief is that the eyes function like cameras, the ears like microphones, and the brain like a screen on which the outside world simply appears. In this view, reality exists fully formed out there, and the mind merely opens a window to look at it. Yet this comforting picture is profoundly misleading. What actually happens inside the nervous system is not a direct reading of the world, but an ongoing act of interpretation, synthesis, an invention that happens so quickly and so seamlessly that it feels like perception itself is the world. When light enters the eye, it does not arrive as colors, objects, or depth. It arrives as electromagnetic energy that stimulates photoreceptor cells. These cells do not contain the color red, the shape of a face, or the meaning of a smile. They merely respond with electrical signals. The same is true for sound, touch, smell, and taste. Every sensory system begins with raw physical changes converted into neural impulses. From that point onward, the brain must transform these impulses into a meaningful experience. Nothing in those signals says, "This is a chair," "This is a friend," or "This is danger." Those meanings are supplied by the brain itself. This transformation is not a passive decoding process. It is an active construction guided by internal models of the world that have been shaped by evolution, learning, culture, memory, and expectation. The brain constantly runs predictions about what it is likely to encounter next. These predictions are not guesses in the casual sense. They are deeply embedded biological strategies that allow the organism to stay alive. Your brain is continually asking, in effect, given what I know and what I have experienced before, what is most likely happening right now? Sensory input then serves mainly to correct or confirm these predictions, rather than to generate experience from scratch. This is why perception feels immediate and stable, even though the incoming information is fragmentary and delayed. There is a measurable time lag between when something happens in the world and when your brain registers it. Yet you do not experience the world as being perpetually behind. Instead, your brain fills in the delay by anticipating what should be there. It presents you with the best guess version of the present moment. So you feel as though you are directly in contact with reality, when in fact you are always living inside a prediction that is being continuously updated. Consider how effortlessly you recognize faces. A face is not just a collection of pixels or light patterns. It is a complex configuration that the brain must assemble from incomplete data, often in poor lighting, partial views, or rapid movement. Despite this, recognition feels instant and certain. This certainty does not come from the sensory data alone. It comes from the brain's powerful face models, built over a lifetime, that allow it to complete missing information, ignore irrelevant variation, and produce a coherent perception even when the actual input is ambiguous or degraded. Illusions reveal this construction process by exposing its seams. When you look at a visual illusion and see motion where there is none, depth where the surface is flat, or color where none exists, you are not witnessing a failure of your senses. You are witnessing your brain doing exactly what it always does, applying its internal models to make sense of limited data. The illusion simply tricks those models into generating a plausible but incorrect interpretation. The same mechanism that allows you to navigate the world efficiently also allows illusions to work at all. The idea that perception is actively constructed also explains why two people can experience the same situation in dramatically different ways. Their sensory input may be similar, but their internal models are not. Each person brings a unique history of memories, emotional associations, cultural meanings, and learned expectations into every moment. These factors shape what the brain predicts and therefore what it constructs as reality. What feels obvious, neutral, or harmless to one person can feel threatening, significant, or emotionally charged to another because their brains are constructing different versions of the same external situation. Even your sense of having a stable self is part of this construction. The feeling that there is a continuous me who exists across time, who owns memories and intentions, is not something you directly perceive in the world. It is a model your brain generates to make sense of bodily signals, actions, and social interactions. This self-model allows you to predict your own behavior, plan for the future, and navigate social life. It feels like an undeniable inner truth, yet it is also a constructed narrative that can change under certain conditions, such as illness, trauma, meditation, or the influence of specific drugs. The fact that reality is actively constructed does not mean that nothing exists outside your mind. There is a physical world, and it places constraints on what your brain can plausibly predict. If you step in front of a moving vehicle, your internal model will be corrected in a very abrupt and painful way. But within those constraints, your experience of the world is not a transparent window onto objective reality. It is a controlled hallucination that balances prediction and sensory correction to produce something that is useful, coherent, and survivable. What makes this so profound is that it reframes everyday experience. Seeing, hearing, feeling, and even thinking are no longer simple acts of reception. They are acts of creation. You are not merely in the world, you are participating in the moment. By moment generation of a world that appears solid, continuous, and self-evident, even though it is assembled from electrical signals and probabilistic guesses. This constructed world is so convincing that you rarely notice its artificiality, and yet it is the only reality you will ever directly know. The idea that the brain predicts the world before it experiences it may seem counterintuitive at first, because everyday language encourages us to believe that experience comes first and interpretation comes second. We say that we see something and then think about it as though perception were a simple recording and thought were an optional extra layered on afterward. In reality, the order is largely reversed. Your brain is continuously running ahead of your senses, generating expectations about what is likely to happen next. And these expectations shape what you end up experiencing. Experience, in this sense, is not something that arrives fully formed and is then interpreted. It is something that emerges from an ongoing dialogue between prediction and sensory evidence. From a biological standpoint, prediction is not a luxury. It is a survival necessity. Organisms that can anticipate what is about to happen have a decisive advantage over those that merely react after the fact. If a rustle in the bushes might indicate a predator, waiting to receive perfect sensory confirmation would be dangerously slow. A brain that can generate a rapid prediction of threat and prepare the body to act is far more likely to keep the organism alive. Over evolutionary time, nervous systems became increasingly specialized not just in sensing the environment, but in modeling it, learning its regularities, and forecasting its changes. This predictive function operates constantly, even in the most mundane situations. When you reach for a cup, your brain does not wait until your fingers touch the surface to decide how much force to apply. It predicts the cup's weight, shape, and texture based on prior experience. Muscles are activated in advance according to those predictions. If the cup turns out to be lighter or heavier than expected, the error is corrected in real time, but the action itself was guided by a forecast rather than by pure reaction. You experience this as smooth, intentional movement, even though it is actually the outcome of a continuous prediction-correction loop. The same principle governs perception. Your visual system does not build each scene from scratch based only on the light patterns hitting your retina. Instead, it uses learned models of how the world usually looks and behaves. These models generate predictions about what objects are present, where they are likely to be, how they are likely to move, and how they should appear under certain lighting conditions. Incoming sensory signals then serve mainly to fine-tune these predictions. When the data matches the prediction, the brain's model is confirmed and your experience feels stable and effortless. When there is a mismatch, the brain updates its model and you experience surprise, confusion, or a shift in perception. This is why you can understand a sentence, even if it is spoken quickly, with background noise or with missing syllables. Your brain is not decoding every sound perfectly. It is predicting what words are likely to come next based on grammar, context, and prior knowledge, and then using the partial sensory input to confirm or adjust those predictions. Much of what you hear is what your brain expects to hear. This does not mean you are constantly hallucinating in a chaotic way. It means that your brain is efficiently using probability to fill in gaps and maintain continuity in your experience. Prediction also explains why habits are so powerful. When you perform a familiar action or follow a familiar routine, your brain already has a well-tuned model of what is going to happen. This reduces uncertainty and effort. You can walk through your home in the dark, drive a familiar route while thinking about something else, or type without looking at the keyboard, because your brain is predicting the necessary sensory and motor patterns. You are not consciously guiding each step or keystroke. You are allowing your internal model to run, stepping in only when something unexpected occurs. Emotions are also deeply entangled with prediction. Your brain does not simply register what is happening in your body and then label it as fear, excitement, or calm. It predicts what bodily state you should be in given the situation and your past experiences. These predictions shape how bodily sensations are interpreted. The same racing heart can be experienced as anxiety in one context and excitement in another because your brain's prediction about what the situation means changes how the sensations are constructed into emotion. In this way, feelings are not raw readouts of your body. They are interpretations guided by expectation. Even your sense of time is influenced by prediction. The present moment you experience is not a direct slice of the external world. It is a constructed no that includes a small window of recent past and anticipated future, blended together to create continuity. This predictive smoothing allows you to experience motion, causality, and flow rather than a disjointed series of snapshots. You feel as though you are moving through a stable present, when in fact your brain is constantly leaning forward in time, projecting what should be happening, and updating that projection as new information arrives. Understanding that the brain predicts the world before it experiences it changes how we think about certainty and truth. It reveals that what feels obvious and immediate is actually the result of sophisticated inference. Your brain is continuously betting on what the world is like, and most of the time those bets pay off well enough that you never notice the underlying uncertainty. But when they fail, you encounter surprises, illusions, misunderstandings, and sudden shifts in how things appear. These are not anomalies of perception. They are windows into the predictive machinery that normally runs invisibly beneath your awareness. What you call experience, then, is not the simple reception of an external reality. It is the outcome of a ceaseless forecasting process, in which your brain constructs a best guess version of the world slightly ahead of the sensory data that corrects it. You are always living just a fraction of a second in the future your brain expects, adjusting course as reality pushes back. It's a statement that what you see is a controlled hallucination shaped by survival rather than truth pushes the idea of perception even further away from the comforting notion of an objective mental camera. It suggests that the primary purpose of perception is not to reveal the world as it truly is, but to keep the organism alive long enough to reproduce and adapt. This may sound unsettling, but from an evolutionary perspective it is both logical and inevitable. Natural selection does not reward accuracy for its own sake. It rewards usefulness. The brains that persisted across generations were not the ones that delivered perfect representations of reality, but the ones that produced experiences and behaviors that increased the chances of survival. When your brain constructs what you see, It is not asking, what is the precise physical structure of the world right now? It is asking, what interpretation of these signals will help me respond in a way that is most likely to keep me safe, functional, and socially connected? The result is a perception that is optimized for action, not for truth. You do not see the world in terms of raw electromagnetic wavelengths, pressure gradients, or chemical concentrations. You see it in terms of meaningful categories, objects, faces, threats, pathways, allies, obstacles. These categories are not part of the physical world itself. They are interpretations that matter to a living body trying to survive in a complex environment. Consider color. Physically, color does not exist as a property in the world in the way we experience it. There are only wavelengths of light, yet your brain turns those wavelengths into vivid reds, blues, and greens because distinguishing between different surfaces, ripe and unripe fruit, healthy and unhealthy skin, and day and night conditions has survival value. The experience of color is not a truthful rendering of electromagnetic reality. It is a useful interface that compresses complex physical information into something that can guide fast and effective behavior. The same applies to the way you perceive space and solidity. At a fundamental physical level, matter is mostly empty space, with atoms separated by vast distances relative to their size. But you do not see emptiness. You see solid objects with clear boundaries. Your brain constructs the feeling of solidity because you need to know what you can lean on, climb, throw, or avoid. The perception of a hard table or a solid wall is not a statement about quantum reality. It is a practical hallucination that helps your body interact with the environment. This survival-driven construction also shapes what you fail to see. You are not aware of most of the information your senses could theoretically provide. You do not see ultraviolet light. You do not hear most frequencies of sound, and you are largely blind to slow, gradual changes in your environment. Your brain filters out enormous amounts of data, keeping only what has historically been useful for survival and social functioning. The world you experience is therefore a simplified, edited version of what is physically present, sculpted by millions of years of evolutionary pressures. Illusions and perceptual biases reveal this editing process. When a straight line appears bent, when a stationary image appears to move, or when two identical shapes appear to be different sizes depending on their context, you are witnessing your brain applying assumptions that usually help you make sense of the world quickly and efficiently. These assumptions are based on typical lighting conditions, perspective cues, and environmental regularities. The illusion occurs because the brain chooses the interpretation that is usually most useful even when, in that specific case, it is wrong. The error is not a malfunction, it is the byproduct of a system that is optimized for speed and survival rather than for perfect accuracy. Your social perceptions are also part of this controlled hallucination. When you look at another person, you do not simply see a moving biological organism. You immediately perceive intentions, emotions, trustworthiness, and threat level. These are not directly visible physical properties. They are inferences your brain makes based on facial expressions, body language, tone of voice, and context. These inferences are shaped by evolutionary pressures to quickly identify allies, rivals, and potential dangers. The feeling that you just know what someone is like is your brain delivering a survival-oriented interpretation, not a guaranteed truth about that person's inner reality. Even pain is a constructed experience shaped by survival. Pain does not scale linearly with tissue damage. It is a protective signal modulated by context, expectation, and perceived threat. In emergencies, people can suffer severe injuries with little pain, while in safe environments, minor injuries can feel intense. Your brain adjusts the experience of pain based on what it predicts will best protect you at that moment. The sensation is real and powerful, but it is not a simple readout of physical damage. It is part of a controlled hallucination designed to influence your behavior. Understanding perception in this way reframes what it means to trust your senses. Your senses are not lying to you, but they are not telling you the truth in a philosophical or physical sense either. They are giving you a version of the world that has been tailored to your biological needs. This version is coherent, stable, and compelling because it has to be. If your experience were too uncertain or too detached from practical meaning, you would be unable to function. The world you see must feel solid, immediate, and trustworthy, even though it is the product of constant interpretation and approximation. This also explains why changing internal states can dramatically alter perception. Fear can make shadows look like threats. Fatigue can make distances feel longer and sounds more irritating. Expectations can make neutral faces look hostile or friendly. These are not random distortions. They are adjustments in the brain's survival calculus, tuning perception to what it believes is most relevant to your safety and well-being at that moment. When you recognize that what you see is a controlled hallucination shaped by survival rather than truth, you begin to understand that your everyday experience is less like looking at the world through a clear window and more like navigating a carefully designed interface. That interface is astonishingly effective at keeping you alive, socially connected, and goal-directed, but it is not a transparent mirror of physical reality. It is a biologically useful story your brain tells you about what matters, what is dangerous, what is safe, and what you should do next. The idea that conscious experience is a biological inference process challenges the notion that our awareness is a passive mirror reflecting the external world. Consciousness is not a simple observation. It is the culmination of an intricate process by which the brain interprets, predicts, and constructs the signals it receives. At every moment, the brain receives an overwhelming flood of sensory inputs from the environment and the body. These inputs are noisy, incomplete, and sometimes contradictory. To navigate the world successfully, the brain must make sense of this chaos, deciding which signals are meaningful, which are errors, and which can be ignored. Conscious experience emerges not as a direct reader of reality, but as the product of these inferential computations. At its core, inference is about making predictions and updating them based on new evidence. The brain is constantly generating models of the world, estimating the causes behind incoming sensory data, and refining these models as more information becomes available. When you see a red apple on the table, your brain is not simply registering wavelengths of light. It is inferring the most likely source of that light pattern based on prior knowledge of objects, colors, and context. This process of inference is what allows you to recognize the apple instantly, even if it is partially obscured or in unusual lighting. Your brain fills in gaps, discounts irrelevant variations, and generates a coherent perception. Conscious awareness is the subjective experience of that inferred reality. Importantly, these inferences are shaped by the brain's prior beliefs, expectations, and internal models. Consciousness is thus both a reflection of the sensory world and a projection of the brain's accumulated knowledge. What you experience is a negotiated compromise between what the world presents and what your brain predicts. This explains why perception can be fooled, why optical illusions are compelling, and why two people can witness the same event yet experience it differently. Each brain constructs its own version of reality, guided by both incoming signals and the internal models that interpret them. The process of inference extends beyond mere perception into cognition and emotion. When you feel fear at the sight of a dark alley, your brain is inferring not only the presence of potential danger, but also how your body should respond. Your heartbeat accelerates, your muscles tense, and your attention narrows, all as part of a predictive model designed to maximize survival. The conscious experience of fear is the culmination of these biological inferences, presented as a coherent and compelling subjective state. Emotion, memory, and attention are all interwoven with these inferential mechanisms, showing that consciousness is never a simple window onto the world, but a dynamically generated construct shaped by the brain's continuous computations. Even seemingly stable aspects of consciousness, such as the sense of a persistent self, are products of biological inference. The feeling of being a continuous, unified agent arises because the brain constantly predicts and integrates information about the body, environment, and social context. This self-model allows for coherent planning, intentional action, and social interaction. It gives the illusion of a singular, enduring I, but this is a constructed narrative, continually updated based on sensory input and prior expectations. In this sense, the self is not a fixed entity, but a running inference, a hypothesis that the brain tests and refines moment by moment. This inferential view of consciousness also explains why our perception of time, causality, and continuity feels seamless, even though it is constructed from discrete neural events. The brain anticipates the immediate future, fills in gaps, and stitches together sequences to create a continuous experience. What we call the know is not a direct readout of the environment, but a predictive synthesis, a biological guess about what is happening based on partial evidence and prior knowledge. Consciousness, therefore, is an elegant solution to a practical problem: how to act effectively in a world where information is incomplete, delayed, and ambiguous. Neuroscientific research supports this perspective by revealing predictive coding mechanisms in the brain. Neurons do not merely transmit sensory information, they compute prediction errors, the difference between expected input and actual input, and use these errors to update internal models. Conscious perception corresponds to the brain's best guess inference after this iterative process of prediction and correction. This framework explains phenomena such as perceptual illusions, sensory hallucinations, and even certain psychiatric conditions, which can arise when the brain's inferential process is biased, imprecise, or miscalibrated. The inferential nature of consciousness also underscores the active role of attention. Attention is the brain's way of prioritizing which predictions and sensory signals are most relevant at any given moment. By focusing on specific stimuli or thoughts, the brain enhances its model in those domains, refining the inferences that become conscious experience. Conversely, unattended information may be filtered out or relegated to unconscious processing, demonstrating that consciousness is not a passive stage where everything is displayed equally. It is an active construct shaped by what the brain predicts is most pertinent for survival and action. Understanding consciousness as a biological inference process fundamentally shifts how we think about knowledge, perception, and reality. It highlights that every experience, from seeing a landscape to remembering a childhood moment, is the product of the brain's predictive modeling rather than a direct apprehension of objective truth. Reality as we know it is always mediated by these inferences, and what we call awareness is the conscious representation of a highly processed, biologically useful model of the world. This perspective does not diminish the richness or significance of experience. Instead, it illuminates the remarkable computational sophistication that underlies even the simplest acts of perception and thought. By framing conscious experience as inference, we can also begin to understand the plasticity of perception and cognition. Altered states of consciousness, meditation, sensory deprivation, and psychedelic experiences all modify the prior's predictions and weighting of sensory signals in the brain's inferential process. These changes produce profoundly different subjective realities, illustrating how deeply consciousness is a construction rather than a passive reflection. What is real in our conscious experience is therefore inseparable from the predictive computations that generate it, showing that the mind is continuously interpreting, modeling, and creating the reality it perceives. The understanding that perception reshapes how we understand identity and self reveals that the way we experience reality is deeply entwined with the way we experience ourselves. For most people, the self feels like an obvious, unchanging core, something that exists independently of circumstances or perception. Yet modern neuroscience and cognitive theory suggest that the self is not a static entity, but a dynamic construct, continuously shaped by the same predictive, inferential mechanisms that govern perception. Just as the brain generates a model of the external world, it simultaneously constructs a model of the internal world, of the body, intentions, and identity, and presents it to consciousness as a coherent, unified self. This self-model is not a passive reflection of reality. It is an active creation tuned to facilitate survival, social interaction, and adaptive behavior. The self is fundamentally relational. From the moment we are born, our brains learn to interpret signals from both our bodies and our environments, integrating sensory feedback, emotional cues, and social interactions into a continuous narrative of who we are. When you feel hungry, tired, anxious, or confident, Your brain is not merely reporting objective states, it is predicting and interpreting bodily signals in context, generating experiences that help guide decisions and behavior. Your sense of agency, the feeling that I am acting, choosing and affecting the world, arises from this ongoing prediction process. Your brain continuously models cause and effect within your own body, producing the subjective sense that there is a stable agent behind every action. Yet this agent is not an unchanging soul or independent observer. It is a running hypothesis, constantly updated based on perception and prediction. Social context plays a critical role in shaping the self. From early development, humans are attuned to the expectations, reactions, and feedback of others. The brain's predictive machinery incorporates social norms, observed behaviors, and anticipated responses into the self-model, producing a sense of identity that is inherently relational. You do not simply exist in isolation. Your brain constructs a self that is optimized for navigating a social environment. This explains why identity can shift dramatically across different contexts, between work and home, in public and private, in the presence of friends versus strangers. The self is not fixed, it is a flexible, adaptive construction shaped by perception and interaction. Memory further reinforces the inferential nature of the self. Your autobiographical memories are not perfect recordings. They are reconstructions, influenced by emotion, expectation, and subsequent experience. Each act of remembering is an act of inference, filling in gaps, emphasizing certain details, and smoothing over inconsistencies. The narrative of your life, the story you tell yourself about who you are, is therefore a product of ongoing prediction and interpretation. Your identity is entwined with these constructed memories. Who you believe you are today is built upon a web of past inferences, constantly revised in light of new experiences. Perception itself directly influences selfhood. The brain does not simply process sensory input to understand the world outside. It uses the same mechanisms to generate an embodied sense of self. Proprioception, interoception, and exteroception, the senses of body position, internal physiological state, and external stimuli, combine to create a coherent experience of inhabiting a body. Your sense of being a distinct entity in space and time arises from this multisensory integration. When perception is altered, so too is the experience of self. Illusions, virtual reality, meditation, and psychoactive substances can shift the sense of bodily ownership, agency, and continuity, demonstrating that the self is inseparable from perceptual construction. What you feel yourself to be is always a product of the brain's model, continuously updated and actively maintained. Emotion is another key factor linking perception and identity. Emotional responses are not raw data. They are predictive inferences about bodily and environmental states. When you feel joy, fear, pride, or shame, your brain is generating an interpretation that integrates internal sensations, environmental cues, and prior experience. These emotional inferences are central to the self, shaping motivations, values, and self-concept. For instance, repeated experiences of social rejection may lead the brain to predict vulnerability or inadequacy, embedding these expectations into the self-model. Conversely, positive reinforcement and affirmation shape a self that anticipates success and belonging. In this way, perception, emotion, and identity are inseparably intertwined. The brain constructs a self that is coherent and adaptive, yet constantly shaped by both external reality and internal inference. The predictive nature of perception also explains why the self can feel continuous despite constant change. Every moment, the brain integrates sensory input, bodily states, and memory to produce a seamless experience. From the first-person perspective, there seems to be a stable, unbroken identity, but beneath this continuity is a dynamic process of construction. The self is maintained as a working hypothesis. The brain continuously predicts its own internal states and adjusts them based on feedback. Consciousness presents this hypothesis as an enduring entity, even though it is inherently fluid. The stability of identity is therefore an emergent property of predictive processing, rather than evidence of a permanent, unchanging core. This understanding has profound implications for personal growth and psychological well-being. Recognizing that the self is a flexible, inferential construct opens the possibility of reshaping identity through changes in perception, attention, and interpretation. Practices like mindfulness, cognitive restructuring, and reflective self-inquiry work because they intervene in the brain's predictive mechanisms, allowing new patterns of inference to take root. By altering the expectations and interpretations that guide perception, it is possible to experience shifts in self-concept, emotional resilience, and social behavior. Identity is not destiny. It is an ongoing construction, responsive to both internal awareness and external experience. Even pathological conditions illustrate the deep connection between perception and self. Disorders such as depersonalization, schizophrenia, or body dysmorphic disorder demonstrate how disruptions in the brain's inferential processes can distort the sense of identity. In these cases, predictive models fail to generate a coherent, integrated self, producing experiences of detachment, fragmentation, or misidentification. These phenomena reveal that the stability and coherence of selfhood are contingent on the same neural mechanisms that construct perception, reinforcing the idea that identity is an emergent product of the brain's predictive modeling rather than a fixed, independent essence. Understanding the self as a construct of perception also invites reflection on how subjective reality shapes behavior and relationships. The identity you inhabit, your sense of strengths, vulnerabilities, and capacities, is inseparable from the perceptual and inferential framework your brain employs. How you interpret events, interact with others, and make decisions is filtered through this self-model. By recognizing that identity is constructed, you gain insight into the malleability of personal narrative, the influence of context and expectation, and the interplay between internal and external worlds. This perspective emphasizes that who you are is not a static fact, but an evolving hypothesis, continuously inferred from perception, memory, and social engagement.